So what we're going to do now requires a bit of explanation. I'm sure you have seen this before in other games. Let's see how we can make ours. So let's say we are playing, and for debugging purposes, of course, I'm going to hit space, and let's say my character runs out of health. So instead of dying, he falls into a last stand mode. Other games might call it something else. So what we're going to do from this last stand, or from this state, of course, I'm not dead yet, and I can also aim. Now, of course, there's a little bit of depth of field that makes it look like blur, okay, because I haven't messed with it yet. So we're not going to focus about that. So from this state, I can move, of course, and when I'm looking behind my character, I'm going to transit into another state, into something that looks like a prone state. Now you shouldn't think this state as a prone, but if you are going to make a prone state, it's going to be pretty much the same idea with it. Okay, and we can move forward. Now of course I had to make all the animations, so do not expect some crazy animations. Okay, and based on where we're aiming, because there were a few problems, okay, when we are looking behind our characters with our AK, some design choices I did was to hide mistakes done by the AK. For instance, what I mean, if we are at the front state and aiming, if we go towards to the point where he's going to change the animation, you will notice that the gun is not aiming towards the sender. Now of course there are ways to fix that, but it will be blown out of proportion of the scope of this video. Okay, and I just wanted to focus on doing everything else before we start doing all the polishing. So what we're going to see is falling into this type of state, making our character rotate based on where we are looking, making our character move, of course, from this state. This uses a whole different way of moving, so it's not nothing we have seen before, because it's more choppier, so that, because you know he's supposed to be injured, so he cannot move at a steady pace. Okay, so of course when we can aim from both of the states and all that, and I think it looks pretty nice. So let's start with the code. We're going to use a new script and a new animator state behavior, which we will see last. We're going to write a new script called last stand. So forget everything we have said before, and you will see why. What we need in this script, we need the input handler, we need a reference to the rigid body, state manager, a collider, a boolean if it's the first frame we are first coming into the state, okay, 0 maximum friction, that's how for movement, horizontal, vertical, our movement duration, so how long we can move towards a direction, our speed, you see that of course we are supposed to be crawling, so it's pretty low speed. If we are moving, if we have face down, if we are a current time where we save, we check our duration and a move direction. When we initialize this, we can pass the state manager, since we initialize this from our state manager. Okay, so instead of using get component, just pass the state manager. We need all these references. Oh, and yeah, I've noticed there's a duplicate, so let's delete this. 0 maximum friction, the same way we done this in the very first video, the very first part. Okay, this is how we initialize. Now, on tick, when we are first initializing the state, we go to the weapon manager and we say if our return current weapon is not the new weapon we are going to make, which is going to be called down weapon on our weapon manager. Then we will crossfade into hit to down state, animation state. We will say to the animator that we will set the bool down to true, and we're going to switch weapons with the down weapon, which is also a unique case of a weapon. And we're going to say to the state manager, this is a dummy model, so do not run any updates on this. And then we say we have initialized the down state. Now, before we see the rest, I think it's best so we can see the weapon manager and how the animator is set up. So let's see the animator. Okay, this is what we had before with everything that we already had. So we're going to make a new sub-state machine. Notice that it's not connected to anything, since this is a special case. That's why I said it's not a prone locomotion, it's a whole different state. So think of this as a whole different animator. It's better that way. And the parameters we're going to use, the new ones, is down, aim front, aim sides, disable AK, and face down. Although disable AK has to do more with the rest of the stuff we have to do. What I need you to do is add on the second state the reload to move to the reload animation. Add the condition so that it only goes if the down boolean is false, and if the aim also to go to the aim is also if the down is false. Back to base layer and back to our down. So we come from in here. This also has the new animator state behavior, which what this does goes into the script we will write and adds force on the rigid body towards the direction we pass over here. Of course, this is relative direction. Okay, it plays the animation, and let's use another model. It plays the animations, he just falls down and moves into another animation which is down to idle, and it plays into our two idle states we have over here. It will start with face up. If you have another animation that falls with his face down, you will make him transit to this state. You can find all these animations into the description, of course. And yeah, I have made all of this, so do not expect something wild. So we are on the idle with face up. If we are going to aim, we'll play this one, and we will see a little bit. This is kind of a special case, this state over here, but everything else is mostly the same. So if we want to move from this state, we will transit, and there is a reason why this is are not inside the blend tree. We will transit into an animation that plays a move. So he makes he plays the animation. You can see he just moves. Same for sideways. The transitions, the way we transit is straight if the forward is greater than 0.1. Sideways is if it's less than minus 0.1. Sideways to the right is if the sideways is greater than 0.1, and the back if it's less than minus 0.1. Okay, and they all transit back with exit time. If we are to aim, okay, if the condition aim is true, then we play the animation state that we are aiming, and if it's false, we return back into our idle. Now, if the animator says, the parameter of our animator says that we are face down, we play the animation that makes him this animation, which is basically turning from face up to face down. Okay, with X time it falls to the other idle state, which is this. This is just this guy type of state. He falls idle and it's a rifle, as you can see over here. So if the face down, the face boolean is down, the face down is false, I move into face down to face up. Now in this case it's the same animation, just reversed on speed, the opposite speed. and yeah, you should probably use your own animation or a better animation than this, so that it looks way better. Okay, and we transit back to idle phase up with exit time. These two states also have a change boolean, and they disable arcade true whenever you enter, and they reset it whenever you exit this state. And that's why, because we do not want any arcade on this, so the player cannot aim when changing idle phases. And in the system we've made over here, we also cannot move when we are aiming, and that's why you don't see these two things connected with all the others one. Of course you can do that, but yeah, this state is supposed to be, you know, it's a handicap state, so yeah, you do not want a powerful state. It's supposed to be as a last stand. Okay, so the same with this. You play the animations based on the same variables as we saw over here. Okay, for each of this, and you return back with X time. When you are aiming and you have face down, it's a single animation. Okay, idle, down, face down, aim. It's this. If if you are aiming and the face down turns false, it will turn back to this state and it will return to this idle, and if you are still aiming, it will go into this blend tree. Now, if we are on this blend tree and the aim state says that we are face down, it will move to this animation state and it will go to the idle, and so on and so on. Okay, simple. Let's see this special case. Now, this is a special case because we have because for the arcade to work correctly, we need to change a little bit the stage. So we start from an animation state that goes and makes him aim towards the left. Okay, and when we are at -1, we aim towards the left. Now, when we are at 0, and from 0 up to 0.8, so I think this is useless, up to 0.8, we want him to keep aiming forward, because the IK is going to take is going to control all the rest. Okay, so for basically an angle that goes like all this and even up to here, it's going to be controlled by the IK, and there's no need to do anything else. But if we are further than angle away, we should do and play another animation. Okay, so he aims from the correct position. Simple enough. We have done this, something like this, in the Max Payne video, but yeah, this is a better implementation, I think, and it's much more complete. So from over here, this is the blend tree. Okay, this is everything that has to do with the animator. Let's go back into our script. Yeah, not everything. We are going to see this script in a bit. So we were over here. This is how we initialize all this. Notice we do not have transitions because we want to crossfade, since this is a special case. And after that, we need to find a direction towards the looking position. To find that, we take whatever the state's look position says, we subtract it from our transform position, and we normalize that. We find the angle, and of course the angle we want from our transform.forward, and the direction to lower towards looking position. If the face down to be true or false, if the angle is greater than 90, then that means we want to look down. Of course we can do this 100 or everything else. I think 100 should be fine. Okay, so if you are looking towards the angle and the angle says it's greater than 90 degrees, then it's going to make your character play the animation and look with face down. This is how we update the animator, if we are aiming or if we are face down or not. And here's a new function we're going to see, which says handle animations. And what it does is takes the vertical and horizontal and just goes and passes it directly to the animator without any crossfade and all that. The way, if you notice that we do not have anywhere input handle or anything that has to do with the player touching either the camera of the player or touching any key, because we can use this, as you might have guessed, with AI too, and it's something we're going to see way later. Now, if we say we are moving, or if we are face down and aiming, then what we're going to do, we're all going to rotate our character if we are moving or if we are aiming, but only if we are aiming and we are face down. Okay, and there is a few reasons for this. It's mostly because we want to hide a lot of errors, because we do not have that many animations and we use the DIK extensively. It's better to hide stuff than make them feel realistic. Okay, the golden rule is you should never let animations or reality come into play or block your gameplay, basically. Okay, games are all about gameplay. Nobody will care if it looks exactly like real life if the game plays if the gameplay is boring. Okay, that's pretty much a golden rule. Now, how we find where we want to rotate? We find the direction towards a looking position, and yeah, we should probably use this one too. Let's use this one. We of course want target direction .y to be 0. We find the target rotation. Now, if we say we are face down, we want the opposite of the target direction, and if we say if we are not face down, then we want the exact target direction it gives us. And then we do a spherical lerp from transform rotation, target rotation, states my delta, basically multiply by 0.5. Okay, we do not want to rotate too fast. We want, as I said, this is a handicap state, not an actual state. So, if we are moving and we are not aiming, as I said, we have no movement when we are aiming. We add to our current time, and if the current time says that our move duration, and for as long as our current time is lower than our move duration, we have our collider material to be 0 friction, and then we add force on our rigid body by moving direction multiplied by a crawl speed, and all that by force mode dot velocity change. Of course, you can play with other force modes. I think this works for what I want to do. I think this works just fine. If we are past the current time is longer than our move duration, then we reset all our variables. So we set our crawl speed to 0.1, move duration to 1, material to maximum friction since we are not moving. We set current time and say we are not moving anymore. Yeah. So, if we are not moving, we need to find the angles, but we will see later what this is. We update our horizontal and vertical based on what our stage.horizontal and our stage.vertical says. From there, we find two vectors, the vertical and the horizontal. So this is the same we do on our exactly character movement. So based on a camera holder, and yeah, this is wrong actually. Yeah, we're going to change this when we are using the AI, but let's keep it for now. So based on our own input, where the camera holder forward is, we multiply that by our vertical, and based on the horizontal, we multiply this by camera holders dot right. Okay, and we have two vectors. If either of this one is not 0, we say move through, and the moving direction we want to move is the vertical plus the horizontal, and all that should be more normalized, but yeah, maybe the normalized is not really that important. So this is how we find our move direction, and this is how we say, you know, we want to move. And we do it this way since if we just tap one of our keys, one of our movement keys, okay, of course the animation didn't play, it made him move. As you notice, you need to press it a little bit until the animator updates, of course. Okay, we are moving like this. Of course, with better animations it will have a lot better, but we do with the resources we have in our hands right now. Or you know, you can give me a mock-up suit and I will make all these animations. So, how we find the angles? So, to find the angles, basically we want the angle towards the loop position and our transform forward, or basically just a direction toward where the loop position is. We need to turn that into local position, and we do that using inverse transform direction with the direction we find over here, normalized, of course. And then we can split our relative position direction to forward and sides, and we are passing the relative position to Z and the X as side, and then we pass that to our actual animator. And I think we do not even need even need the aim front anymore. So I'm going to delete this, and from over here I'm going to delete this one as well, and I can also delete this one as well. Okay, this is how we say it plays this state and only this state. Now we have another function that what it does is we can use it from any other script to add movement this way, with adding movement for a duration of time towards that direction this way. So what this does is, this function is, it's perfect when we are playing the animation that we are falling down. We can add force backwards, so that means, yeah, you know, it visualizes a bit the momentum of a hit. So it takes the relative direction, the duration, and the speed. It turns the relative direction from local position to wall position using transform direction. We pass that as the move direction. We say we want to move. Move duration will be the new duration, and the crawl speed will be speed. And that is why we have to reset them over here. Since I know my values, I can reset them directly to what I want to have. Okay. If you want to have variable values, or change them easier, make them public floats, store them, you know, and use this instead of hard coding it like I do. Okay, simple. And that's basically it for this script. Let's see the animator state behavior that makes us add velocity down from our for a character backwards, not down. Okay, add movement on state enter. What it does, okay, we pass direction, duration, speed, and we need a reference to the last stand script on state enter. Of course, if the last stand is null, go and find an animator go and find the script last stand. We do another check if the last stand is null, so if this returns nothing, then we are not running the next type of code, if you do not add this, if you cannot find the last stand script, then it's just going to give you an error. So if we have a last stand reference, we say add movement, direction, duration, and speed. So how we are using this? I purposely left these two states without adding any forces, and I just only use the disable IK, which we will see where we actually use the disable IK. And because, let's see our case, when we are down and we are changing, okay, you'll see it will look a bit better if he also moved a little bit towards the position before he changes, of course. So let's go over here and let's get there. Let's add movement on state enter. The movement I want to be is, let's say, 0.1, or I think, yeah, since it's duration it doesn't matter, we want this. And for duration we're going to make it as 0.3, and speed, let's give it 0.2, since it's a zero friction material. So the same with over this, add movement on state enter. We want to move to the left since it's the opposite of this animation, and I'm going to use the same values, 0.3, 0.2. So without going into any of the scripts, yeah, and I did that opposite, but you will see that he has a little bit of movement. So let's come over here and make this 0.1 and make this to 1. Let's try this again. Let's go to this side this time. I'm moving to the side because jumping back it makes him clip through the wall, or not clip through the wall, you know, the camera clips through the wall. So anyway, okay, you nearly cannot see it because it's just the natural movement of motion, or what your brain expects. Okay, it expects his hips to move towards the right, so it pretty much doesn't register that the character just moved a little bit. So that's what we have to cover about the script. Now we need to see the changes we have to do into our previous scripts. Now on my input handler I've added, I think I only added one thing, that was this 4 lines. Okay, this is for debugging purposes. Okay, you do not want every time you hit space to fall into that case. And if our state says we are down, or on the down state, then our target state for our camera, as we saw on the previous video, will be a new enum I've added, which is camera state type dot down. So on camera state you need to add the down, and on the inspector you need to add a new case into all the other cases we had, as you remember from the previous video. Okay, all that down, and change to the position you want it to have. These are the values I want to have, and I'm also ignoring the Y since I cannot crouch. Now on the state manager, which is mostly the bigger changes we have to do, here's what we are doing. I've added public boolean down if we are on the down state or last down state, or however you want to call that, and we say a reference to the last stand script. Okay, and we also do not need it, so we hide it in the inspector. We need to initialize it, so we get the get component last stand. If we have the script, we say initialize the last stand and pass this state manager as the reference you have to pass over here. And then on fixed update, we come over here and say if we are down and if we are at last stand. Remember that if we are down and we have the last stand script, it will come over here and say this is a dummy model, so all these updates will not run. So everything we had before is not going to run, or at least it's not going to run from in here. So we have some stuff though that we need to have them, so there's no need to duplicate code and write them again. For example, we have array handler, we have a handle shooting. All this stuff has nothing to do with what we are going to do. Has nothing to do with the state we are using. Okay, so there's no need to even run those updates. So we're going to come in here and say bypass angle clamp is a new boolean. We're going to see on the array handler. Okay, we just turn that to true. We still use the array handler, so we call that update. Of course, we need to call the update for the last stand. Handle animation, there's no need since we handle everything on the last stand script. Handle shooting, because we can shoot from that state. And audio manager, yeah, because we have audio too. Let's go to the weapon manager now, since I forgot to mention that. Where was it? It's probably over here. Now, the only thing I've added into the weapon manager is the same way we have our unarmed weapon reference based, the same way we're going to have a down weapon. So this is the weapon we are using when we are at the last stand stage. Okay, we're going to just take it so that the character has a weapon every time he falls, has a pistol every time he falls, so we're going to just open that one pistol. Of course, you can change to what pistol you want and all that. So into our character, we have to go into the weapon manager, and we will have we have our available weapons, we have our weapons list, okay, our unarmed weapon, and we also have the new weapon we're going to add, down weapon ID, weapon ID we can add down weapon model. I'm just using the ones I've already have from my weapon. Okay, and yeah, you have to set it up exactly as any other weapon. Nothing that doesn't even change. Okay, the one thing I did change though is I made some new. Let's open a prefab to watch it better. I made some new IK targets exactly for this one. Since this is kind of a special case, I do not want to use the same IK targets with this one, so I can have way more control over it. Okay, so I placed the hand targets, the rotation, and I also have my elbow target underneath my right hand targets, because so they can move together. Okay, we have seen this, how to set stuff like this, weapons like this, a lot of times, so I'm not going to go over them again. So this is basically what you need to do, or what you need to set up this. And since it's just a new script, it's easier to implement it into, or remove it if you don't want it, into any type of game that uses this system. So we need to see the few changes we have on array handler. Now, most of the changes I've did are pretty simple. Okay, one boolean disable IK and one new public boolean bypass angle clamp. If you remember, the way we have array and wait, we're looking the angle, and if the IK angle where we are looking towards, the angle goes greater than 90, we were taking care of we were closing the IK. Now we're going to add, or if we want to bypass the angle clamp, so we're going to add on this if statement, or bypass the angle clamp, always have target weight at 1. Okay, that's pretty much what it is. And inside this function, the aim weight, we can also say if we want to disable the AK, target weight will be 0 and the look weight clamp it directly to assign it directly to be 0. Okay, so this makes it close the AK exactly at the point this will turn true. Of course we control the left hand AK weight differently, so we need to add it over here. If disable AK, left hand AK weight equals 0, and or disable the AK like this. Okay, the other cases where we're disabling our left hand AK, we can just use this instead of writing target, of copy pasting this in here too. So basically I think we have all that is, we have covered everything based on for this system. Of course, as I said, it's not if you had better animations, oops, they are good pals, as you can see, and they fall, they stay together, they fall together. That's how it is, you know. So, as I said, and yeah, because we had, I know why this happened. Because I have my own space, I have him to also jump on top of cover. That's why that happened. Okay, and whatever state I am, when I'm debugging the fall, like this, it will play the animation. And we're moving, and we're aiming. Of course I need to fix the depth of field, but I think it looks, even with the depth of field like this, it looks pretty good, since, yeah, so like you have blurry vision because you are dead. And one other thing I haven't fixed is that the weapon basically has infinite ammo. Okay, because why not? Because we have to go into our handle shooting, and when we are reloading our weapon, which is should be somewhere, probably somewhere over here, carrying ammo equals 0, if empty gun, carrying now, and states node down. Okay, if we are down, do not reload it. Of course, if you want to reload, if you are down, you should play a different animation. Basically, most of what I do is to circumvent the fact that making new animations take a long time, and sometimes, yeah, I do not have the time to do new animations. Okay, we keep shooting. So we're out of bullets, so we are basically dead meat. So I've covered everything we had to cover in this part. We're still going to make a lot of the stuff, as I said, for this project. There's a lot of cool stuff coming, trust me. So, you know what to do. Like, subscribe, Patreon or Gumroad, it's entirely up to you, so we can continue, keep making some cool stuff like this. And I'll see you next time.